Hello everyone, welcome to the Cyber Investigation course. This session is about handling computer hardware. It's very important to be able to handle hardware, as the hardware is the major source that we actually analyze for forensic examination. The objectives of this session are to describe the importance of being able to recognize different types of computer hardware, which are very important as the investigator understand the computer hardware, he or she will be able to acquire the digital evidence easily. And the various disk drive interfaces that an investigator can encounter, as well as the types of devices used to forensically extract data from different storage devices, and also the variety of storage media used and how this evidence should be handled and analyzed, which will give an example. And also the use of storage media in actual investigation is also covered in this session, and please follow the session as well as the textbook assigned for you. You should develop an understanding of computer hardware for a number of reasons. Certain types of systems and hardware support only certain types of software for operating systems, file systems, and also applications. For example, it's important to understand that an Intel-based Mac can support both macOS and its related APFS and HFS plus file systems. Nevertheless, that same computer can also support a Windows operating system and related NTFS file systems when Boot Camp is running. You can find information about Boot Camp on the Blackboard's this week's content folder. Being cognizant of the diversity of computer hardware is also very important, as you need to know how systems can be connected to external devices such as routers or external hard drives. These connected devices such as routers often contain digital evidence and may need to be seized if a warrant permits, obviously. The investigator might also need to reconstruct the computer and its devices when she returns to the laboratory. So the examiner has to have a knowledge of the computer system in details so that he or she is able to reconstruct the system again and show that the system was working in certain conditions or in certain design that was used by the suspect. Computers have different parts and a set of standards for physically connecting and transferring data between computers and peripheral devices are needed. Small computer system interface is called as SCSI. Although uncommon today, still computers use SCSI connectors. SCSI is a protocol for both the physical connection of devices and the transfer of data. It includes hard drives, tape drives, scanners, and also CD drives. It also works with PC and Apple Macintosh computers. Hard drive interface refers to the connection method used by hard drive to communicate with computer, and different interface has its own features and usage scope. The hard disk interface in the picture above is IDE, and the interface is divided into three parts: power connection, jumpers, and IDE interface cable from left to the right. And controller largely based on IBM PC standards. A hard disk controller, HDC, is an electronic electrical components within a computer hard disk that enables the processor or CPU to access, read, write, delete, and modify data to and from the hard disk. Essentially, an HDC allows computer or its processor to control the hard disk. The disk controller is built into the drive itself. The disk controller actually facilitates communication between a computer's central processing unit and hard disks. So it helps the hard drive communicate between the computer's central processing unit and the hard disks. Bus, data highway, or data bus are all interchangeably used actually. And in computer architecture, a bus actually is a communication system that transfers data between components inside a computer or between computers. So it helps the data transfer between different components of the computer that we've been talking. Another interface that we should talk is, which is a newer interface, is a SATA interface that connects devices like hard disk drives to host bus adapters. SATA provides higher data transfer rates than parallel ADA and largely replaced IEDE devices, which was a former common interface. And most common hard disk drive interface that an investigator will encounter today are actually the ones that I'm showing here, and whether it's a desktop or a laptop or an iMac or MacBook, SATA drive is more common than the rest of the interfaces today. SATA disk drives has rotary hard drives with spinning platters and a moving needle that writes data to consecutive sectors on each platter. And they are actually incredibly fast compared to their processors. And single drive can range from 500 gigabyte to 600 terabyte and are available at a lower cost, which brings an advantage for consumers. In the past sessions, we talked about imaging and copying a hard drive in a forensically manner. And there are two processes are used by computer forensic examiners for making a bit-by-bit copy of a hard drive. They are disk cloning and also disk imaging. Disk clone is an exact copy of a hard drive and can be used as a backup for a hard drive because it's bootable just like the original. So it's almost like cloning a sheep, and it has exactly the same properties, same features. You can actually have that hard drive and use as it was being used by the suspect, and that will give you opportunity to analyze some of the programs that the forensic software may not be able to view in an actual manner. So let's say you want to analyze an accounting program. Even though you can analyze that the information in the accounting program and its database, but you may not be able to use an accounting program with an interface, and you may not be able to see how the program was working. And actually this cloning gives you an advantage to see the hard drive exactly as it is, and it's a big advantage. But it's also a very expensive solution because this cloning exactly copies the hard drive in the same size. So if you are copying a 500 gigabyte hard drive, then the hard drive for the copy will need to use 500 gigabyte as well or more. So this is a more of an expensive method to forensically copy a hard drive. And cloning devices are right protected. That helps the investigator clone the image, and you're seeing a cloning device on this presentation. And before the investigation, all harvest disk drives must be sanitized. Sanitized? What this means is that you have to, you should wipe the hard drive that you will use for copying the image of the suspect's hard drive. When a new hard drive is removed from its packaging, it should be securely erased for storing digital evidence. Disk image is although has the disk imaging although has the same purpose, uh, it's got different features. A file or a group of files that contain bit-for-bit copies of hard drive is imaging, but it cannot be used for booting a computer or other operations. The image files can be compressed, so in terms of the size of the image and the copy of the suspect's drive, you will have a much smaller size image. The process of cloning a hard drive is faster process than imaging a hard drive. So when you are imaging a hard drive, it'll take much longer time. The time difference between the two processes is actually substantial. When a computer forensic examiner works undercover or perhaps needs to obtain a copy of a hard drive and leaves the computer with custodian, cloning drive is more actually practical. Removal of hard drives is another subject that's important for the forensic examiners. A simple internet search for removing the hard drive will result in actually helpful documentation that data has made available online. And removing the hard drive from an iMac is a very involved process, more complex, that requires some actually unique tools. So you already need to have such tools. Apple provides a comprehensive instructions on the removal of hard drives from iMacs, and you can also use YouTube to find quite a number of videos to actually remove hard drives for different brands. When you start copying a hard drive and then actually start analyzing the hard drive, one of the first things that you should notice is the HPA, host protected area. Manufacturers normally use this area for recovery purposes. A host protected area, or HPA, is an area of hard drive that is normally inaccessible to the user. Its existence is not reported to the BIOS or to the operating system of the host computer. In this sense, it's a hidden area of the hard drive that can contain data in many formats, ranging from a raw code or files to complete alternative system or data partitions and even disk image of operating systems. Digital forensic examiners are well aware of the possibility that an HPA could be present on the hard drive they are examining. So HPAs are actually produced by the hard drive's producer so that the uh, hard drive already has actually recovery information itself. Solid state drives are fairly new technology as compared to the previous types of hard drive we introduced. Solid state drive, or SSD, is a non-volatile storage device found in computers. Files on a solid state drive are stored on memory chips, unlike hard drives, in a stationary layout of transistors, not on metal platters. And they have no moving parts, and they can be found in Chromebooks, MacBook, Air Pro, and PCs, and they are actually more efficient alternative to the hard disk drives. The main difference between a solid-state drive (SSD) and a hard disk drive is how data is stored and accessed. An HDD is a traditional storage device that uses mechanical spinning platters and moving read and write head to access data. On the contrary, SSDs are newer, faster drives that store data on instantly accessible memory chips. So it's the SSD is not does not have a rotating arm, and it can actually very fastly it can actually access to the data directly from the memory chip, which brings a faster transfer of data. Unlike a hard disk drive, data must be erased before a write can occur on the SSD. Operating system actually does not keep track of physical locations of files, and the flash translation layer is an intermediate system made up of software and hardware that manages the SSD operations. Garbage collection is essentially an SSD operation that separates valid active data from invalid, actually deleted data, and moving valid data to a different block on the SSD. So if the data is active, and which means it's not deleted, the SSD actually moves the valid data to a different block on the SSD. It then clears the invalid data blocks, making the space available for future writes. So it's actually more challenging than traditional hard drive as a result of garbage collection process. And garbage collection is actually a memory management process that removes unused files to make memory available. And uh, because of its nature, garbage collection is rather an unpredictable situation with the solid state drives, SSDs, and it's particularly problematic for actually cybercrime investigators, as recovering data is much harder than traditional hard drives. Random access memory is a volatile memory that's used for processes currently running on a computer. When a computer is powered off, the contents of RAM are generally erased. However, if a system is powered on, RAM can provide a forensic examiner with a treasure trove of information, which can include internet search, websites visited, and possibly even passwords. So for a forensic examiner, computer forensic examiner, the live analysis of the RAM is very important. So in the past, the forensic examiners usually were directly pulling the plug and were losing the information on the random access memory. But in today, in many cases, it's very important to keep the system alive and analyze the random access memory so that a password can be accessed, or more information about the internet search, websites visited can be acquired. Redundant array of independent disks RAID is commonly known by system managers. A redundant array of independent disks is where two or more disks are used with one another. The two provide increased performance and reliability through the redundancy. Reliability actually refers to fault tolerance, which means that if one component, this part is important, is if one component in a system such as hard disk drive fails, the system continues to operate with the actually advantage of fault tolerance. Although RAID contains multiple hard disks, the operating system views the RAID as one logical disk with the use of hardware controller. So if one of the hard disks fail in the system, then the other hard disk will continue to provide the same information. At that time, actually, the system administrator can actually replace the hard drive or fix the problem. Although RAID contains multiple hard disks, the operating system views the RAID as one logical disk with the use of hardware controllers. So it's important to know that a computer may have multiple hard drives which may be subject to a cybercrime investigation. USB flash drives are another component that's very important for the forensic examiner, that actually the forensic examiner must actually search for USB flash drives and other types of storage units when there's a cybercrime investigation. The file system found on a USB flash drive is actually usually a version of FAT. And Iron Key USB devices use AES 256-bit encryption, and this is an important type of encryption, and very hard to crack this encryption. It's important to consider all potential storage when drafting a warrant and when conducting a search. There are generally two types of external hard drives: a USB-powered hard drive and external drive that uses the USB interface for data transfer but uses an adapter to power the drive. Housed within the casing, an investigator usually finds a serial ETA hard disk drive. This is important to know because if there's a limited amount of time to acquire evidence, or the external hard drive cannot be removed from the premises, it's probably advisable to remove the hard disk drive from the outer casing. By removing the drive from the casing, a cloning device can be used to make a copy of the external hard drive. If the hard disk is not removed from its casing, the drive must be imaged using a write blocker connected to a laptop. So cloning basically provides a faster way of copying the bit by bit information on the hard drive. Here you see an example of Western Digital external hard drive for imaging and validating the drive. An investigator can bring FTK imager light on a USB or on another imaging tool, obviously, and you should not disconnect an external hard drive, as it may have a drive encryption such as BitLocker drive encryption, and it may take a lot more time for you to deal with the BitLocker drive. And contents of the flash memory cards is also important. for the forensic examiner to analyze. There are few ways to securely view the contents of flash memory cards. One tool is Digital Intelligence's Ultra Block forensic card reader and writer, and this device is connected to a computer via the USB port and can read the following media: compact flash, micro drive, Memory Stick Pro, and many other types of media. Secure digital cards or SD cards are file storage devices that were developed for use in portable electronics like cameras. They were commonly used by cameras. SD cards are Wi-Fi enabled with pre-installed utilities. Some of these utilities can actually automatically send photos to a mobile drive, upload files to social media sites, or even add files to a cloud service. And for these reasons, the investigator should be aware of potential wireless capabilities of the SD cards. We have mentioned about a lot of different storage devices in media, and you can read many of them from your textbook, and feel free to ask me questions if you are having any issues in understanding the uh, features of those devices. In this exercise, we're going to actually mount a raw forensic image of a floppy disk, which is actually a raw image with the extension of DD, and you'll actually see the contents of the floppy drive. And you can also find the relevant information on the content folder for the week 10 and lab 1 presentation. When you actually start the access data FTK imager, I actually shared some information about how to open the or install and open the FTK imager in the previous sessions. And when you open the access data FTK imager, you just need to click to add evidence from here, and then from the window opened, you just need to choose image file and then click next. And you also need to add the path, the source path of the file to actually to mount the file. And after you mount the DD file from the access FTK imager, you can actually do the things I described on the content folder and in the discussion. Thank you very much, you all, for listening to this session. I hope the last lab was pretty straightforward. If you need help, please feel free to reach out to me anytime. Thank you.